Good morning, children. In today's class, we are going to learn some examples on transition probability matrices. Example 1.25, we are given a transition probability matrix. We need to find the market share of each brand, say A and B, at equilibrium position. What is the transition probability matrix given? Let us copy as it is. A, B, the two brands, let us write on top as well as in the side. The values are 0.9, 0.1, 0.3, 0.7. Ensure that the total is 1. 0.9 plus 0.1 is 1. 0.3 plus 0.7 is 1. So always I can declare A plus B is 1 or B equals 1 minus A. Now my question is at equilibrium. We will say AB, as I multiply with the transition probability matrix, I must get AB. That is the meaning of equilibrium. So at equilibrium, AB multiplied with T gives you AB. Let us substitute. AB into, what is the transition probability matrix? 0.9, 0.1, 0.3, 0.7. That should give me AB. As we multiply row by column, A into 0.9 plus B into 0.3 equals the first element. First row by first column gives me the first element. Wherever B comes, let me write 1 minus A. This 0.9A I can bring to the right. A minus 0.9A. As we multiply, 0.3 into 1 minus 0.3 into A. That is, here the number is 1. Whenever there is no number, I treat it as 1. A is common, 1 minus 0.9. As we simplify, 0.3 equals 1 minus 0.9 is 0.1 into A. This minus 0.3A, bring it to the right, plus 0.3A. As we simplify, 0.1A, 0.3A. I add to get 0.4A, that is 0.3. Or I rewrite 0.4A is 0.3. A equals 0.3 divided by 0.4. Cancelling one decimal, it is 3 by 4, that is 75%. You can also use calculator to arrive at the answer. If A is 75%, B is 1 minus 3 by 4. That is 1 by 4, or I can say 25%. So in equilibrium position, shares of A will be 75% and B will be 25%. Let us take and write the answer as a statement. Example 1.26. Bharathi is either sad or happy each day. So this question is about being sad or happy. So let us say transition probability matrix based on being sad or happy. Let us say S for sad and H for happy. If he is happy in one day, he is sad on the next day by 4 times out of 5. Happy in one day. So I am here. Sad on the next day. Happy to sad. On the next day by 4 times out of 5. So happy to sad, it is 4 out of 5. So the remaining, it will be happiness. So 4 by 5, what is the remaining? 1 minus 4 by 5. That is 1 by 5. The next line, if he is sad on one day, so he is sad. He is happy on the next day by 2 times out of 3. Sad to happiness. Sad on one day, happy on the next day. So sad to happiness 2 times out of 3. So this is 2 by 3. Obviously, the other one must be 1 minus 2 by 3. So let us write it properly now. It is 3 minus 2, 1 by 3, 2 by 3. Second row, 4 by 5, 5 minus 4, which is 1 by 5. Having known the transition probability matrix, let us proceed to the question. Over a long run. So over a long run says equilibrium. So at equilibrium, what is the formula that we know? SH, sadness, happiness. The transition probability matrix, when I multiply, I must get SH again. And we remember the condition, S plus H equals 1. My question is about happiness. So, I do not want sadness, rather I want happiness. So, wherever S comes, I can write 1 minus H. As we substitute, I get 1 by 3, 2 by 3, 4 by 5, 1 by 5. This is transition probability matrix. When I multiply SH with that, my answer should again be SH. As I multiply row by column, SH 1 by 3, 4 by 5. So, S into 1 by 3 plus H into 4 by 5. First row by first column should give me the first element, that is S. Wherever S comes, let us put 1 minus H. So, 1 minus H into 1 by 3 equals S is 1 minus H. 4H by 5 will go to the right side as minus 4H by 5. As we simplify, 1 into 1 by 3 minus 1 by 3 into H equals 1 minus H minus 4H by 5. Bringing H all to one side and number all to the other side. Minus H will go as plus H. Minus 4H by 5 will go as plus 4H by 5. Minus H by 3 will be as it is in the left. Here I have 1. Plus 1 by 3 will come as minus 1 by 3. Taking LCM for 3 and 5, it is 15. As I cross multiply, 15H plus 12H minus 5H equals 3 minus 1 divided by 3. Cancelling 3 with 15. As I simplify, it is 27H minus 5H, that is 22H divided by 5 equals 3 minus 1 is 2. I need only H. It is 2 into 5 by 22. As I cancel, I get 5 by 11. Let us take and write the answer. Example 1.27. Akash bats according to the following traits. If he makes a hit, that is, if he is successful, there is a chance 25% that he will make a hit his next time at bat. So, first time successful, again successful is 25%, that is 0.25. If he fails to make a hit, so S for success, F for failure, let us take. If he fails to make a hit, that is I am here, there is 35% chance that he will make a hit his next time at bat. Fails at the moment, there is 35% chance to win. So fail to success 0.35. Let us fill the remaining. This is 1 minus 0.25 and this is 1 minus 0.35. As I rewrite, we get SF, success failure, given to be 0.25, 0.75, 0.35 and 0.65. As we check in each case, S plus F is equal to 1. So the question says in the long range. So we will write at equilibrium. So every time look out for a word that which describes equilibrium. So the long range tells us at equilibrium. We know SF. I multiply with a transition probability matrix. Again I get SF. So this is the meaning of equilibrium. Here SF. The transition probability matrix is 0.25, 0.75, 0.35, 0.65. That is equal to SF. As we multiply first row by first column, 0.25 into S plus 0.35 into F equals to the first letter S. Row by column. First row by first column gives me the first element. Wherever F is coming, I can put 1 minus S. My question is batting average. I need to find out S. So wherever F comes, let me put 1 minus S. 0.25 S I can take to the other side. 0.35 into, in the place of F, let me put 1 minus S. This is 1 S, bringing this to the other side, minus 0.25 S. As we multiply, 0.35 minus 0.35 S. 1s minus 0.25 S is 0.75 S. 1 minus 0.25 gives me 0.75. Taking S all to one side, I have 0.35 equals 0.75 S plus 0.35 S. As we add and simplify, we get 1.10 S is equal to 0.35 or S is equal to 0.35 divided by 1.10, or else I can say 35, deleting the two decimals, 35 by 110 or 0.318. Let us take and write the answer. Akash long range batting average is 0.318, or if I multiply by 100, it is 31.8%. We can also calculate failure range, but since it is asked long range batting average, we need to write success as our answer. Example 1.28. 80% of students who do max work during one study period will do max work again. 80% who do max will do max again. So, transition probability matrix, we have max as the subject. Max, again max. We have 80%, so it is 0.80. 30% who do English in one period will do English in the next period also. So the other language given is English. So we have Maths and English. 30% who do English will do English again. So English to English we have 30%. So the remaining I have to fill up here. Here 1 minus 0.80. Here 1 minus 0.30. As we simplify, we get 0.80, 0.20, and this is 0.70, 0.30. So the transition probability matrix we have achieved. What is the next line? Initially, 60 do Maths whereas 40 do English work. So initial study we have again Maths and English. How many of them do Maths? 16. How many of them do English? It is 40. So initially the study is shared as 60-40 for Maths and English. Now the question is the transition probability matrix which we have done here. Second part, the number who do Maths and English for the next subsequent 2 study periods. Let us go one period by one period. So after one period, how am I to get the share? The initial study we will multiply with a transition probability matrix, that is 0.80, 0.20, 0.70, 0.30. How are we to multiply? Row by column. 60 into 0.8, 48, plus 40 into 0.70, 28. First row by first column is done. Now first row by second column. 60 into 0.20, 12. 40 into 0.30, again it is 12. As I add, I get the answer. 48 plus 28, 76. 12 plus 12, 24. So this is after one period. Now my question is after 2 study periods. So after one period, what happens? We'll multiply with a transition matrix again. So 0.80, 0.20, 0.70, 0.30. As I multiply, first row by first column, 76 into 0.8, 24 into 0.7. First row by second column, 76 into 0.2, 24 into 0.3. As we add, we get 77.6, 22.4. Because it deals with number of students, let us approximate. 77.6 can be treated as 78. 22.4 can be treated as 22. Altogether, the total must be 100. As in the beginning, we had 60 plus 40, 100. 76 plus 24, 100. We must get 78 plus 22, also 100. Cross verification is good. Now let us take and write. This is Maths and this is English. So we had Maths, English like that way. So my answer, this represents Maths and this represents English. So after 2 study periods, there will be 78 students who do Maths and 22 students who do English work.